Okay, let's talk about some scientific notation. Scientific notation is probably something you're familiar with from another class. It is used in chemistry when we deal with really large numbers or really small numbers, and it's also useful if you're trying to show only a certain number of significant figures, gets rid of all the extra placeholder zeros that are just holding a place. So for scientific notation, and if we take a large number like 15,000 and we want to put that into scientific notation, the way we're going to do it is, even if there's no decimal point, we're going to look at where the decimal point would be if it existed, so right after the ones place. And basically we can count over however many places it takes for me to move the decimal point to get to a number between 1 and 10. Okay, so that's the rule for the base number, always has to be a number between 1 and 10. So I'm going to start here, and I need to go over 1 space, 2 spaces, 3 spaces, 4 spaces. So if I put the decimal point here, this number 1.5 is going to be a number between 1 and 10. If I were to have left it here, that would be 15. That's obviously a number that's greater than 10. If I went one more place, that would be 0.15. That would be a number that's less than 1. So again, 1.5 is going to be, we'll call that my base number. And my base number in scientific notation always needs to have the same number of significant figures as the original number. So in this number, we learned to count significant figures the other day. This has 2 significant figures. These zeros are just the placeholder zeros. So the whole purpose of scientific notation, again, is partially to get rid of those numbers, those placeholder zeros, because they're not technically significant. Now, there's also this times 10 part, and since I moved over the decimal point 1, 2, 3, 4 places, then that's going to be times 10 to the 4th. And what this notation means is we have the number 1.5, and then it's times 10 4 times. So if you actually plugged that into your calculator and multiplied that out, you would get back to this 15,000. Okay, so that's what this is representing. Again, my base number needs to be a number between 1 and 10, so that's one of the rules, one of the criteria we're looking for. And also it needs to be containing the same number of significant figures as the original number. If I have this as my example, so let's say I have 0.042. So there's the number I want to put in scientific notation. This case, this is a number that's less than 1. So I need to work in a slightly different direction and be moving the decimal point to the right in order to get to a number between 1 and 10. So in this case, I'm going to go 1, 2, and if the decimal point were placed here, that would mean that I have a base number of 4.2. So again, that's a number between 1 and 10. These two are the only significant figures. Remember, the leading zeros before the first non-zero digit, those are not significant, so they're not going to show up in the scientific notation number. And then times 10 to the, in this case, if I'm moving the decimal point to the right, because I had a number less than 1, then this is going to be a negative exponent on the 10. So I moved it 2 places to the right, so this is going to be times 10 to the negative second. And what this is representing is if I had 4.2 divided by 10 times 10, right? So again, if you plug that into your calculator, this is the number you'd get. So divided 4.2 by 100 essentially is what you get. A couple other things we need to know about scientific notation. On most of your calculators, so I'll talk about this in class with you, how to figure out how to work it on your calculator. But every calculator denotes it a little bit differently. The format that I just showed you with the times 10, that's the way that I want you to write it on your papers. Again, with significant figures. So let's look at this case, 0.0050. What we learned about counting significant figures. Leading zeros, so any zeros before we get to the first non-zero, those are not going to be significant. We're not going to see that appearing in our number. We start counting significant figures with the first non-zero, and then if there's a decimal point, we're just going to keep going once we hit our first non-zero and count. So this is 1, 2 significant figures. Now the reason this is important is when I go to write my base number, again, I'm going to move my decimal point over. I'm moving it to the right this time. 1, 2, 3. So 5.0, and then I moved it 3 places, so this is going to be times 10 to the negative third, since that was 3 places to the right. Again, in this case, I am putting this 0, so when I write the number like this, 0 is also indicated to be significant. When there is a decimal point, any zeros at the end of the number we do count. And so this 0 was significant in the original number, and it's still significant in the way I've written it in scientific notation. Another real quick thing, if you have a number that has units at the end, so 1200 meters, if I'm writing it in scientific notation, so again, here would be my decimal point, moving it over to the left 3 places until I get a number between 1 and 10. So that would be 1.2 times 10 to the third. If there's a unit, it goes at the end of the number. Okay, so it's going to be after the times 10 and the exponent. A lot of times I see people sticking the units in the middle, and that would be kind of like if I just did, if I was writing the number 1200 and wrote an M right in the middle of the number. That doesn't make any sense. So likewise, any units need to go at the end of these numbers as well. When you go to use numbers in scientific notation in your calculator, again, I will show you a way to put them in to your particular calculator. That's why it's important that you have a calculator that you're familiar with using in class, so that on the test you're using something that you're comfortable with. All of them have a little, idiosyncrasies to deal with, but you might want to consider using parentheses when you're working with these in calculations, and we'll work through some examples in class so that you can see why that is. But again, if I wanted to put this in parentheses for a calculation, you need to type it in with the parentheses around the whole thing. So after you put in the base number, and then the times 10 and the exponent part. But we'll get into that in class. So that is a brief summary of how you can write numbers in scientific notation. In all of your calculators, as long as you have a scientific calculator, they can do this for you. If you don't need to put a number in scientific notation, if you haven't been specifically asked for it, you don't have to. Again, in terms of reporting numbers with the right number of significant figures and reporting numbers that are very large and very small, this is very useful.